Hi, everyone. So many people, and like normally I say hi to everybody, but that's gotta go away. I was just commenting that we had to pick up the dog from the vet just before this, like 15 minutes ago. So I'm like, came home and scrambled to get everything up and rolling. So it's good to see everybody. Let's see. I see Brandon. I see Andrew. Hey guys, nice to see you, Andrew. Used to seeing you with glasses, man. Yeah.
One of the benefits of a career switch, thanks to boot camps, I could afford LASIK.
There you go. That's awesome. Okay, so just a couple of housekeeping things. Let me just do the quick Aftercamp primer thing, and then some life updates, and then we'll get into Docker and Kubernetes. So if you are here or watching the recording, welcome to the Aftercamp Meetup. Aftercamp is an idea that Rachel and I had a long time ago. We have significant experience in the bootcamp space, but we are definitely seeing areas of opportunity post bootcamp, really in that 0 to 2 year space. And sometimes actually I'm finding that we're doing a lot of content that like some 3 to 5 year developers want to do. So we needed an outlet to help continue to help people. So we came up with Aftercamp Meetup. And there's some other stuff in the works beyond just the meetup. So we're excited about that stuff, and we should get at you with that by the end of the year. Let's see, some quick life updates. I did change jobs this past few months, and you probably just go ahead and tack on again. Yes, I moved on from Artisan Technology Group, which is awesome. It's a great company out here in Kansas City. Went back home to Nerdery. So I'm in my third tour at Nerdery now, principal software engineer, working on some super secret stuff that hopefully someday I can tell you all about. But super cool, super happy to be back. Very cool projects. And I think I'll actually really help create some more content for Aftercamp. So it's pretty exciting. Let's see what else. Yeah, so apologies for the setup. We did move. So we are kind of working through that. Still got to find my camera and get that all set up, but that's neither here nor there. Hopefully the audio is good with the big broadcast headset. So hopefully that's at least working for. Not that any of what I look like, but because we're going to be talking Docker and Kubernetes tonight. Okay, so I want to set this topic up just because it's interesting. So boot camps and self-taught have really risen, I would say, even in the past 10 years, although boot camps are roughly only 7 years old. And one of the things, the interesting kind of byproducts of both self-taught and bootcamp is some things that they teach in CS may or may not be picked up as you kind of progress through your career. Now, I'm weird. I think I'm technically self-taught. My degree is in game design. I come at the web through a completely different tech stack. And so I still lack some of the traditional CSE things. Now, to complicate for me even more is that I worked at Geek Squad for a number of years as my high school job in college. I was really, really close to computers and hardware and networks and all this stuff. And it didn't occur to me when we started Prime Academy, the bootcamp, that I'm most strongly tethered to, that computer literacy and digital literacy it definitely has variations. I think that everybody kind of comes at the internet with a different level of expertise. But really what is behind the internet is even more dicey. I mean, you may or may not even have some of that experience that goes on, like beyond the browser. What do you know? Like, what do you know about your operating system? What do you know about your hardware? And so I think in order to set up the Docker and Kubernetes conversation correctly, we're going to start with just some kind of like, I don't want to even call them fundamentals because that's not really fair. None of the stuff that we do, friends, is easy or fundamental. I think all of it is got a extreme complexity to it. But I wanted to have a conversation about Docker and Kubernetes, but really have a point of to this from a boot camp. I'm going to take what I think you know, and we're going to kind of expand upon that. So all the classic broadcasting problems, Macs only come with 2 USB-C ports. I don't have a monitor hooked up, and I got whatever. So I'll do my best to check for questions. And then Rachel, if you want to just interrupt me, if I don't see a question in the chat, just let me know. I'm already missing chat. Okay, cool. There we go. So let's go ahead and do a screen share and start talking about the internet. Go away, Zoom. Okay. Can you all see my lucid chart? Okay.
Yep.
Perfect. Okay, cool. So if you've ever done anything with me, if I ever taught you, and if you've ever attended Aftercamp, you might be familiar with this diagram, although I typically draw it like this, where we have kind of these 4 core pieces that make up what we would to be a web application. So we have our front end, and this is really like HTML, CSS, anything that we see. This is what I typically refer to as the clients, and that represents any client-side application like JavaScript. This would be like your React, your Angular, all of that code kind of lives in this place. And then there's like this imaginary line, or I suppose it's not somewhat imaginary, it's really like super physical, where we reach out beyond our client application and we reach out to a server. And server would be like your Node Express, it would be like your .NET, your Java Spring, Django, Flask, etc. That's what this is right here. And then we have our database, and this is like your Postgres, your Mongo, MySQL, that sort of thing. So when we are developers, we typically develop across the full stack, or you might specialize in one particular area. But if you've gone through a boot camp, chances are excellent they taught you this kind of setup. And the thing I think, as being a person who has taught boot camps for 4 or 5 years, I feel like it's a little glossed over, and I probably have glossed over it quite a bit as well too. So I want to take a step back and kind of just explain how this setup works. Quick reminder too, if you could go ahead and mute yourself, that would be amazing. I'm getting some feedback from someone's audio. Okay, so really just at a high level, something I want to explain. Let's go ahead and add in just some additional shapes here real quick. So got my library, come on. And there we go. Okay. So when we develop, like I said, we code all pieces of this experience. And so, but the core thing to understand is like not to think about like where you develop them or what you're developing, but rather the big conversation tonight, where those things actually run. So the point here is that if you think about the front end and the client side code, that typically will run in our browser. So we basically build an application that is then loaded by something like Chrome. And really that is even running on your operating system, and that is even running then on your computer. So I don't have a nice little operating system icon. Let's see. Let's just use this guy for today. So we would have something like Chrome running on our Mac OS, and that is running on our Mac computer. And these 3 things are actually running our code. So in order for our code to run, it needs to have a browser to run in. It needs to have the browser needs an operating system to access, and the operating system needs to have hardware to access. So it takes these 3 components to run our code. And also, you're developing locally. You would then also have this kind of setup too, where you have some hardware running, let's just say Mac, that runs our server. And then the same is true for our database, where we have some hardware that is running Mac OS, that is running, let's say, Postgres. So when we develop, these 3 pieces of hardware and operating system are all the same. But a key thing to understand is that technically you have 3 applications running, one for the client side experience, one for the server side experience, and one for the database. And I feel like that fact alone is often glossed over when you are learning development for the first time, right? Because, we're used to just saying something like, well, hang on one second here. I'm just going to go ahead and mute everybody. Let me just figure out how to do that real fast. Getting some gnarly feedback. Let me stop sharing. Apologies, 1 second. And almost there. Okay, no, everyone's muted. Oh, all right, well, go back to screen share. That person might have caught themselves. Cool. Okay, so when we are running our applications on when we're developing, we would say something like, let me just get in here real quick. Come on. Oh, for love of. right, CD, let's go into our Docker example. My tab is not working tonight. There we go. Okay, and so we'd say something like npm start. And npm would start, and this is running because I have Docker running. So let me just kill this, and I promise I'll get back to it. Ugh, my apologies, friends. Let me turn this all off quick. I promise we will get to all of this. Stop and stop. Okay, so I'm going to start my application. We'd say something like npm start. So this would be the equivalent of me saying, okay, I'm going to turn on, in this case, my server. And so my server is now greenlit, like we are now turned on. And that is basically set up and waiting for connections. Then if I were to go to something like my browser, I could go ahead and access that. And I think I put it on 3000, hopefully. And very basic front end experience. But basically what we have here is we have my front end that connected to that server. So I hit localhost 3000 and I hit enter. And what ended up happening was my browser reached out to my server, and my server responded with an application that it's now running. So we now have the green kind of check for this application is running. Now, if I wanted to start Postgres, I'd go into something like terminal using say something like brew services start Postgres, and that would turn Postgres on, which is my database. So when we first learned development, we have this thing where we don't necessarily put that all together. We don't really make the connection that these are three separate apps that are running at any given time. But the key thing here I want to continue to echo and continue to reiterate is that this application, this client-side application, is running my browser, that's running an operating system, that's running on hardware. My server is an application running on my operating system and running on my hardware. Database, same thing, running on my operating system, running on my hardware. But they are three applications, and they communicate with each other through these standards. So certainly for client to server, we use the HTTP protocol to communicate to the server. The server actually has the same kind of setup, a little bit different, but three applications running, and they're all talking together. But when you're a full stack developer, when you first kind of approach this full stack development, you're really a lot more focused on syntax, right? You're focused on kind of following those patterns, following those conventions, and saying, I need to create my server. I need to, turn my server on. I need to create my front end. And you're worried a lot more about the JavaScript than you are necessarily about the other, these other hardware pieces, or these other kind of like network communication pieces and these layers. So if we can kind of just pause there for a second, I guess, any questions about the way that applications run on our computer? And as you're typing those questions in, one more point that I want to make. Our server, we had to install Node. And so I think it'd actually be even fair to say that Node, gosh, I have a little icon for this one. I don't. Let's just go ahead and make one over here. Node is even operating as an intermediary here. Node is running on our OS, and that is running on our hardware. So server file, the Node runtime is being used to run that server file. The Node runtime is running on the operating system. Operating system is running on the hardware. All right, let me check for questions super fast. Rach, I can't see. There it is. No questions in chat. Okay, great. So let's talk about the Docker and Kubernetes and the problems that they solve. So one of the things that I've noticed as I've gone through my career as a software engineer, helping other people and really helping myself as well too, is that we get to something like deployment, or we get to something like code share, and we're working on a team together, and we need to go ahead and work on a project together. And we run into things where, let's take a classic example. I'm developing, and I'm developing a full stack application. I have my front end, I have my back end, and I have my database. And I'm working with a team member who's coming off another project. And let's say that I'm using like the typical like React, Express, and we'll go with Mongo. We'll go with a MERN stack here. So Mongo, Express, React, and Node. And the person who's coming onto this project is actually getting off a Postgres project. So they had basically had a different setup. So they were, let's say, React, Node, and Postgres. So they're coming into this project not having MongoDB installed onto their machine. Now, when you think about that problem, you think about, okay, well, if that was me, what would I do? And without something like Docker, we would go ahead and say, okay, great. You need to go install Mongo onto your machine and basically set it up with this configuration. Kind of a classic problem. Or let's say that you have front end, in which case this would be true anymore. Let's say they're a React developer and maybe they don't have Node installed, which would actually kind of be impossible. Or you're working with somebody who is maybe just like, maybe they're, okay, this is a great example. They are a cloud engineer. They don't do development, but they need to run your code on their machine. And so let's look at it from that perspective. You are a person who is going to work in AWS or GCP. You're not developing, but you need the code base and you need it running locally on your machine. Well, what would you have to do? Well, you'd have to go install Node. You would have to potentially install React scripts. So you'd have to install the database. You have to install these different pieces. And so that's really where I think Docker starts to shine. It certainly doesn't end there, but I think it starts there. And that is what happens in Docker is that it starts to work with something called a container. And a container essentially is all for you running without the need to actually install these things. So let me show you a little graphic from Docker's website. It would help if let's scroll down to it. Okay. So let's look at the left-hand side first. And what Docker actually is it has the ability to essentially, it is an installed application. So it's an application you download from Docker's website. You can run it on your machine, and Docker is actually like a composition of products. So Docker is not, for example, Docker Desktop. It is, that is one of the tools within Docker. Once again, just friendly reminder, make sure you're muted. But Docker itself, as kind of like the runtime environment, basically what it does is it runs, and then it can run the independent applications and basically take care of all of the configuration and setup for you. So what I mean by that is here, what Docker is doing is we'll just take it's running my server and it's running my database. And what's cool is that if the person receiving the application, receiving my code bundle, I should say, has Docker as well too, they can just run my container without actually ever having to install any other of the dependencies needed for that project. So in the case of, let's say this cloud engineer who's working with AWS, they just wants to test the code quick. If they have Docker on their machine and I created a Docker image for my application, they can go ahead and download the Docker image and run it. And basically what that does for them is everything works basically just as soon as they hit, Docker Compose up, let's say. So it gets the application up and running without them actually having to download things like Mongo and Node and so on. And there are basically Docker can support a number of different frameworks, a number of different languages and such. You can dig into that. And I definitely don't want to get into nuances. On this idea that the problem Docker can solve is this configuration and setup problem. Now, beyond the inter-developer problem of me sharing code, this is also becomes extremely powerful when we go to deployment as well too. Because if I create a Docker, image or Docker, a container that has all of my different apps running, so my front end, my back end, and my server, I can just deploy the container. And I don't need to worry about setting up and configuring all of the other bits and pieces of my apps. So an example of this would be, let's say you're using something like Heroku. And Heroku is an awesome free cloud platform. You can get into, come on, I just want just Heroku or whatever, I don't want to sign in. Let's deploy your app to Heroku, and then you'd separately deploy your database. You'd kind of have to configure those two things independently. So you have to go through and say, for the database, you have to set up all the credentials. You'd need maybe set up like, in the app itself, all the username and password for the database, that sort of stuff. And so you basically at post deployment, you have to go in and kind of do that additional configuration to those applications. Whereas if you were to create a Docker or set up Docker for your applications, your application bundle, you can actually configure that all within something called like a Docker file. And it doesn't matter where you put it, as long as it supports Docker, and all the major platforms support it. So AWS, GCP, and Azure all support Docker. And so you can actually just throw the Docker image up, and then it knows what to do as long, send it with the code bundle. So at a high 10,000, once again, kind of just to echo this again, the problem that Docker solves is one that may or may not be obvious to you if you're getting into development. When you're getting into development, you are starting your server that's listening for connections, and it serves back the client application that's running on a browser, that's running on an operating system, that's running on hardware. And then typically databases can be kind of set it and forget it. Like you can just tell your database to start as your computer starts. So you may have started at one time in your life, in your development life. And what you don't necessarily see is you have really these three different applications in these three different runtime environments running on the operating system at once. And you usually don't really become painfully aware of all of that until you start to deploy something pretty significant to a service like Heroku or AWS's Elastic Beanstalk and so on. So I'm gonna pause there again before I hop into like code stuff. Questions, comments, concerns, disbeliefs? Is this jiving so far? You guys is it making sense?
So Scott, if I want, are you hearing me?
Yeah, I'm hearing you, man. Go for it.
Let's say I'm working with AWS and I want to, transition to Azure. Is it an easy transition if I have everything in a Docker container just to move all my stuff from AWS to Azure?
In short, maybe. So I mean, it depends, because the problem in both of those cases is if you, sorry, let me back up. The answer can be yes. If you have set up those services to receive containers and we're working with simple hosting, yes. If you are tying it into, let's say something like AWS Lambdas and you're switching over to Azure Cloud Functions, then it can be tricky. But if you are just hosting your applications, yes, you could hypothetically take your container and move it. And that's kind of the strength of it, is that digital replatforming piece can be significantly easier as long as you're set up that way.
Okay. So they hook you up, with other things that you need to connect to your Docker to make it a little bit impossible for you to switch providers or whatever.
Yeah, you're getting into a topic called digital replatforming, and let's say we're making the switch. I'm going to say from Azure to AWS because I don't like Azure. Don't tell Microsoft that. So let's say that we are moving off Azure and we're going on to AWS. And sorry, I do like Microsoft if you're listening. All good. But let's say that you have your server call out to, let's say, a cloud function. So this is some sort of API request out to a cloud function. If that function is written in Azure, depending on how you coupled it, you hypothetically could move the hosting of all of this over to AWS, but call the Azure cloud function. And so once again, this is where I get to, it's a little bit how you set it up. But if you have I'm just trying to work through examples in my head quickly. The short answer is it can be really easy. It can be super easy to do with Docker, but the more tight coupling you do, it can be more difficult. So, and by the way, that is a great question, because that is a very common thing to come up right now in agency work, is digital replatforming. The reason why there's a term for it is because a lot of people are doing it. They're moving from one service provider to the next. So, and typically it's people migrating off of AWS, Azure, and GCP. They're usually coming from something else. I'm gonna make something up here like HostGator or whatever. And they're moving their hosting over to one of the bigger providers. So digital replatforming is pretty common.
Thank you.
Okay, so what I want to go through is I'm going to go through a very simple code example. We're going to leave Docker out of it for just a second. So I just want to talk you through the setup of what the project actually is. And I'm going to bump this up a little bit so y'all can see. Get rid of my terminal. And here we go. PS, I pulled this example off of a tutorial. I just recoded it. And what was nice about that is I can just share those tutorials out with you all. And that way you guys can go through the step-by-step of how this application got built. So I think it'd be a really nice follow-up if you want to go through the motions that I've gone through here. I thought it fit in really well with tonight's conversation. So what we have here is we have a super simple, there's basically no front end to it. It's all back end. It is an Node Express written in JavaScript, so there's no TypeScript involved. The code is generated using Express Generator, which if you've written Express code, you may or may not have come across Generator before. What's nice about it is it's using npx command to generate kind of like a base Express project. So it sets up things like the bin, the public, the routes, largely hooks up most of the app for you. And it's pretty turnkey. You can turn it right on if you wanted to. One pattern that's in the Express Generator that you might not be familiar with is the bin www pattern. And so let's take a look at this really quick and talk about the entry point for this app. One minor update that I made is that Express Generator uses lots of var. So I just did update it to be a little bit more modern syntax. It uses using like var and function instead of the standard syntax. So let's go through this super fast. So here we have, let's go back to app. Here we are creating an Express app. It's using path down here to join the static files, which I'll go to in a second. Typical stuff if you're working with some sort of like ability to receive data incoming to the server. So usual suspects here are cookie parser. You might be wondering, where is body parser? About 2 years ago, Express rolled body parser into Express. So you can now, instead of using body parser.json and body parser.url encoded, it's actually just built into Express now. So that's pretty cool. So cookie parser is there. There's a logger called Morgan that's pretty common. And then we have our routes, which I'll get to in just a second. Then we get our app, so which is just an instance of Express. We're using the logger middleware, and this is really just about generating the equivalent of console logs and getting some pretty messages, like look through what's going on. Here we're turning on the ability to receive JSON data. We're also turning on the ability to make it easier to get data off the incoming request from the client. We're turning on cookie parser. And here, this is the line of code that allows for static file serving. So this would be, you want to serve like an HTML file. And so that's set up to be wired into the public directory, which here we have the index.html, which is super basic. Express, welcome to Express. So basically this line of code goes ahead and says, let me go ahead and give you static files. So your index, your style sheet, client-side JavaScript, that sort of thing. Then we're wiring up our routes, which I'll get to here in just a second. And then we are bundling up the app. And then this is the pattern that most people are not familiar with. Here we have, we take in and consume that app in the www file, turning so we're requiring something called debug. More on this in a bit. And then the HTTP modules here. And essentially I won't get into all of this code tonight, but we're doing things like making sure that as we're receiving the port name, we're set up to receive it in string or in number format. We're ensuring that it's the right formats. So this would be there because if like you're deploying to a service provider like AWS or Heroku or something, if for some reason they don't provide you an int, it goes ahead and converts that for you, so you're not dealing with like a string. Let's see what else is in here. A couple of methods to handle errors, and then listening. So this tells us that we go ahead and we're listing on a specific port. So essentially, this turns on, gets everything kind of up and running and working. So a lot of people aren't used to seeing the server.listen and the server.on and listing separated from what's our standard app file, but this is the recommended pattern. So essentially, when we say npm start, it's running off the www file. So that's really that entry point. That's the kind of the biggest difference. Okay, so the important pieces of the app, really, this is all boilerplate except for one thing here, and that's this line where I bring in the person's router, and then I use the person's router. So let's go take a look at that. The person's router uses something, sorry, blanking for a second, is going to use something called Sequelize, which might be a little bit different. So that's also going to hook into something called the database module as well too. So standard stuff you'd see in Express apps. We bring in Express, we set up a router. This handles our routes. So here we have get all, we have get by ID, we have post at the base routes, and then deletes by ID, and so on. Here, what this is doing is basically is using this DB module to find, replace by primary key, add entries, and delete. So if you're not familiar with this really quick, let me pull this up. The database file is using something called Sequelize, which is really, really cool. If you're coming into web development with like Postgres, you might have come across a module called PG, and PG allows you to write raw SQL and use that to query against your database. Sequelize locks it down a little bit more. And so you get some things kind of out of the box. You define schemas and the structures of how that should look. And what's cool about that is that if you're coming from PG where you're writing raw SQL, you'll only get errors back when your data doesn't conform to the way the database wants it. So this brings it up forward in the stack, and instead you'd get your errors in the server rather than the database. So just really quick here, this actually handles the database connection too. So here I'm actually connecting to my database, connecting to Postgres with the Scott Reminder user. This will be specific to your machine. And then localhost 5432, which is the standard Postgres port. And so, yeah, here I'm establishing the connection. This would be similar to like your pool if you're working with PG. And then we're defining a very, very basic, essentially like schema for a piece of data. So here I'm defining the person. Then all they have is a first name and a last name. And what's nice is that we can define type to make sure that we're getting the right type. And then basically say that we don't allow null. It has to be filled with something. So the DB connection, essentially, we define the connection itself. That's step one. Step two is defining what data is actually going to get saved into the DB. And then we export it for use back in this person's route. And the next thing that might not be super obvious to you that wouldn't pop up if you haven't used Sequelize is the built-in methods for getting data out of the database or making updates to the database. Instead of writing raw SQL, you instead can use the methods provided. So here we're using a find all, which would be very similar to like a select star. So here we're saying, hey, database, go to the person schema and find all of them and send them back. And here we're just parsing out the or stringifying out the person. So it just comes across as a nice string. Same thing, we can go ahead and get a person by ID. That's find by primary key or find by PK. Finds that person, returns it. Post says, let's create a person. There's the model there for that. And then delete uses the destroy method. And then we use this where option to say like where, and we can specify what key we're concerned about and how we, what needs to match. So long story short, sorry, I know it's a huge rant. Here we have a simple server that is connected to a database that is working with a person's table. That table has first names and last names. So pretty simple data structure, first name, last name. So let's follow the intake, right? So let's go ahead and say request comes in, it comes onto the person's route. So request is falling through the system. That's how I kind of describe Express. It's falling through the system and we're doing, let's say, a get request on the person's route. It gets picked up by this person's router. The person's router then gets that request. So remember, it's a get like get all requests. So the request is coming in like this. Get persons all. And so remember, the way that Express works is that if it's already matched on the last module, it drops that off the URL request. Now we're just looking for get onto all. We've matched here. We say get all, reaches into the database, finds all the persons, and then sends that back to the front end, or sends it back to the person who made the request. So let's look at that graphically. Some sort of client makes a request to whack persons, whack all, goes across, gets to the server, the Express server module, the persons module receives that request and says, we're going to get all of the persons. So it uses SQLize to connect to the database to get that data out, send it back to the server and says, hey, I found all the persons. I'm going to send it back to the front end. So this app is indeed 3 separate applications running all at the same time. Pause there for a second, see if we have questions.
So Scott, that's the response is coming back as a single string. Is that what the stringify is doing, or is it coming back as an array of strings? Or
yeah, it's just coming back as a however the database sends it back. I think, you know, if we say persons all, we got an empty array right now, but how it comes back is less important. It's just more the fact that all 3 are running, I guess, is the point for tonight at least. But
okay,
yeah,
cool. Thanks, man.
Yeah, dude. Okay, so when we go to deploy this application, think about the steps that you would take with what you've learned so far, right? We would do something where we effectively say, okay, we are going to do, you know, gets add dot. We would do git commits. We'd say final update. And, you know, you would push to maybe GitHub, and then maybe you'd go about saying something like git push Heroku main. You're pushing that main branch. So you're basically effectively taking your server side code and your client side code and you're pushing it up there. Now, out of the box with this push, it's going to solve 2 problems. And it's because Heroku is set up to solve those 2 problems. It's going to solve these 2 problems. It's going to solve the server problem, and it's going to solve the front end problem. And largely it's going to solve the front end problem because the server gives the browser the front end. So Heroku has actually already figured out how to set this up for you. So what you don't see that's happening is that Heroku is sensing that you have, in this case, node code. So it goes ahead and partitions some of its hardware. It partitions and provisions an OS, and it in that OS, it provisions node. Heroku does all of that for you when you say Heroku create and then Heroku push. So Heroku creates the endpoint, and then once it receives that first batch of code, it says, oh, you're building a Node app. Let me go ahead and install Node, and let me go ahead and take your code and get this thing up and running. The way that it used to work is that you would have a server room in your office, and you'd work with IT to say, hey, I need a Linux setup, and I need on that Linux machine, I need Node running. So one of the best things about Heroku from a learner standpoint is you don't have to think about any of that. The worst things about Heroku is that you don't need to think about any of that. But as you kind of enter the industry and you start, you know, working with these cloud providers, and you start thinking about, okay, what do I want, or how do I want to set up the hosting of this? All of a sudden, you actually need to be thinking about that. So if you walk into AWS, let's say, and I want to, and with that, I want to provision an OS, you actually need to dictate all of that. And you're like, well, hold up a second. I haven't seen that before. Like, why, you know, why are you asking me what operating system I want to run? Can't you just do it for me? And I think this is where like the biggest friction point, I think, comes in for a big stopgap for 2 things for new developers. One stopgap is this problem of like, gosh, I really like didn't have to think about this with some of my simple hosting solutions. It just did it for me. I think I'll just go back to Heroku. And then the second problem is like, you got to like think about this problem kind of globally as well too, because like you do need to get your app live, like you need to get it up and running. And we haven't even solved the database problem yet, right? Because I can push my code to Heroku right now, but I still have to go back and use a separate command to say, oh, I also want to provision a hard drive and I want to prevent, you actually have to specify like what kind of hard drive, so or database rather. So I say, oh, I want to Postgres. So you get a little flavoring of that, I think, in the flavoring of all of this problem when you actually have to provision the hard drive in Heroku. Luckily, it's like 1 or 2 commands, one to set it up and one to migrate the data. But when you move to these bigger cloud providers, this is all of a sudden becomes a much bigger problem that you might not be accustomed to. So you can definitely, I think learning the hardware operating system and really getting more into the IT function is valuable time to spend. And I think that is important because you might not always be able to use Docker, but Docker becomes a simpler solution to that problem, but obviously more difficult to than just simply using Heroku or something like a simple service like that. So Docker becomes kind of the next step of like your progression into what we refer to as IaaS or IaaS, or infrastructure as a service. It's not true IaaS, but it does solve an IaaS related problem. Okay, so let's take a look and see how Docker solves this for a second. So let me go ahead and close up all of this for a second. So Docker essentially is something, here you can see that the way that this project is structured, I have Docker K8, and I'll explain K8 in just a second. I have my application files, and then I have my Docker files. So Docker file is basically tells Docker how to run specifically your application. So the application itself, right now we are focused on the server application. Remember, we don't have to really think about the front end one, because the server will give a browser the application code to run. So really we're focused in on this problem right here. How do I host in Docker my server application? So here the thing is, in use node, I specified a specific version node here. We're saying, go ahead and make a directory, work in this directory, add a user called app, copy this Docker example file in, run npm install on that file. So it's going to go through and set up all the node modules, set ownership, run the app user, expose port 3000, and then go ahead and run this code. So npm run pm2, which I'll get into here in a second. So essentially the Docker file becomes the launch instructions for how does Docker, well, like, great, you gave Docker the files, but what should it do with it? So that's what the Docker file becomes. And really what this is saying is go ahead and start the server app. And then you're probably like, well, what about the database? Glad you asked. So we have a separate tool called Docker Compose, and Docker Compose is another tool in the Docker toolchain that solves the basically multi-app problem. Now, once again, I'm going to discard this app because the server is going to worry about it. So really, we're just focused and fixated on these 2 apps. So in Docker, how do I basically get these 2 apps going? So we go back over and we're going to look at the Docker Compose file. And what we have here is we are basically saying, I don't want to launch just one application. I want to launch 2 applications. And for the sake of brevity and the time tonight, we'll kind of keep it a little bit simple, but essentially we're saying, go ahead and turn on the Postgres image, turn that on first, right? Because we know that our Docker example, our application needs to connect to a database. And so this needs to be live first. So we say, go ahead and start the Postgres, go ahead and start the Docker example. And then here we're defining the Docker example DB as a volume, which is right here. So it needs a place to store. You can read more about this in the tutorial, but essentially what we're doing is turn on the database and turn on the server. And then the server will serve the front end app to the client. So that is essentially kind of all of the setup for Docker, besides like installing Docker and whatnot. I did include a commands file here. But once everything is up and running, I can actually just go ahead and in my terminal here, rather than launch all of the products separately. So rather than launching Node separately, rather than launching Postgres separately, I can use a command that says, hey, Docker, use Docker Compose and get it up and running. So I hit enter. It's reading my both my Docker file and my Docker Compose file. And the application's up and running on its command line. You're right. It's not running on my command line because when I'm running applications on my command line, I'm running it on my hardware. When I'm running it with Docker Compose, I'm running it through Docker. So what's cool is that the Docker desktop app can actually show these apps running right now. So here you can see that the Docker example is running on port 3000, which I defined. And then the Postgres example is running on port 5432. So currently Docker took my application into its environment and said, cool, I will get it up and running. And now this is running and I can actually connect to it. So if I go ahead and go to my browser, remember that this is the only terminal I got open right now, other than this one, which I will delete just for proof. So none of my terminals are running either my server nor my database. It's just Docker running these applications. So now go to localhost 3000. I get Express so we can see it's wired up, and that you're like, okay, cool, that's neat. What about the database? Let's say persons all, and actually had some stuff stored in there from before. So going back to the question, what does it look like? I know that this is super ugly. I wasn't really focused on front end, but this is basically showing that there is data tucked inside of that database. So this proves essentially that Docker is running the database as well too. So what's cool about this is I can bundle this up and I could just give it to Chris Johnson. I thought we were talking earlier. I could just give it to Chris. And if Chris had Docker running on his machine, he could take that Docker image and just run it. And he wouldn't have to do any setup or configuration. It would just be good to go. If I wanted to deploy it to AWS, I could use AWS's Docker service to say, just deploy my container, and that thing would be up and running. I could run it through Azure, I could run it through GCP. All of them, all the major service providers have container support. So let me see the chat here real quick. Yes, so MySQL is built into Docker. You can get a full listing of, like, they support Spring, they support, you can get a list of all the services that Docker supports, but oh gosh, I don't know who codes Oracle anymore. I do have the Docker extension on VSC. I want to keep right on. I hear you. I only tease. So there's a Docker extension for VSC as well too. So it shows us something similar to the desktop. I want to get into Kubernetes really quick because I think Kubernetes is like a huge mystery to a lot of people. So give me just a couple minutes to explain Kubernetes. Let me go ahead and kill off these services for just a second. So I'm going to go ahead. Why is the setup of the DB not in the Docker file? Database, turn on and wait for connection sort of thing. Hang with me for just a second. Okay, everything is turned off. I want to show just in something here really quick. I'm going to flip into the server directory. So I'm inside the server right now. And I want to show you just a cool module called PM2. So we're going to say npm run PM2. Now what PM2 is that it's a really cool extension, or not extension, but module that you can pull in. And it gives you all sorts of like cool controls around like load balancing in multiple instances. So let me just show you here real quick. What PM2 is essentially doing is it's running 4 different instances of that one application, and they're all connected to the database. So essentially, in a weird way, I'll explain why here in a second. I don't have one server. I have 4 servers. So I have 1, 2, 3, 4 running. And what's nice is that in the front of this is what we call a load balancer that is basically saying, watching traffic coming in from, let's say a client, and it's running into the load balancer first. And it's essentially distributing the calls between the 4 running servers. And you're like, well, gosh, why would you ever want to do that? Well, the simple answer is, what if you have 1 million users? What if you have all of a sudden next year you have 10 million users? What if you have 50 million users? What if all of a sudden you have 300 million users on your website? One server and its dedicated operating system and CPU is not going to be enough to handle 500 million users. And so what we do is we scale up the amount of instances we're running of this server, and we put in a load balancer in front of this to essentially say distribute traffic across multiple instances. So here I'm using PM2, and I'm actually just dictating this. Like I could actually just say 20 instances. I don't know if I'm just going to bork my memory here, but let's give it a shot. So if I go frozen, that's what happened. 1, 2, yep, all the way up to 20. Now all of a sudden I have 20 instances of my application running. My computer is bogging down a little bit here, but here we actually are dictating through PM2 the amount of instances that we run. So let's go back down to 4. And what's cool about PM2 is it has that load balancer to basically handle that traffic. So I could basically say, hey, PM2, go ahead and deploy to the Docker service. PM2 will basically say, cool, and that within a Docker service, we're going to deploy multiple instances. The trick to this, though, the trick to PM2 is it's not very smart. It'd be a lot nicer if I could essentially handle but I want to go ahead and scale down and scale up the instances based off what's going on and how much traffic is coming in. So I want 5 here. I want 3 now. Traffic's really slow. I just want 2. Just kidding. Now I need a bunch more. It'd be cool if there was some sort of auto scaling component to the intelligence of this app. And in a nutshell, this is what Kubernetes starts to do. So if you're not familiar with Kubernetes, Kubernetes and Docker typically go hand in hand. So Kubernetes is a platform that takes containers, typically generated by Docker, although there's a big article on Kubernetes abstracting out away from just using Docker. But the idea is that Kubernetes works with containers and comes with a lot of features out of the box. So here we can say we can scale our application, and essentially these two things are paired together to solve balancing problems. What's really great is that you can do health checks through Kubernetes. And so you're like, oh gosh, instance 3 of my server isn't responding the way that I want it to. So it runs an audit on it that says, gosh, you know what? Server 3 is sick. Let's go and tear it down and then set it back up again. So it automatically checks the health of your instances as well. Not automatically, I tell it to you, but it can check the health of your instances as well. And so Kubernetes essentially takes this concept of saying, well, Docker solves the app problem. That's the problem that Docker solves, is how do I create a standardized way to have my application environments talk to each other in a highly portable way so that I can share it with other people using Docker, or I could share it with the platform that's going to host it. That's the problem that Docker solves. The problem that Kubernetes solves is says, gosh, what if I need multiple instances and I need additional features to what is running? And this becomes especially powerful when we start working with things like microservices. What if we have not only our application, but we have additional applications in our ecosystem as microservices talking to multiple databases? And so here we have, and you're probably, oh my gosh, Scott, like stop going crazy here. But what if our server talks to additional microservices that have their own data layer? And so one of the things we can start to manage in Kubernetes is, well, gosh, just this service needs scaling. This one's pretty slow, no big deal. This one has got a lot of traffic. And so Kubernetes starts to say, oh gosh, just this piece of this Docker is getting hit up like crazy. Let's go and scale up. And you probably heard this talked about before, where with like AWS and certainly GCP and Azure, like auto scaling. Well, under the hood, a lot of these are just running Kubernetes and Docker, to be completely frank with you. So Kubernetes is kind of the tool, or one of the tools behind allowing that functionality to actually happen. That would be a solution, yes. And the question was, so would it be accurate to say if I want to load balance on my containerized app, I would deploy my Docker image to Kubernetes? Yep, that would be a way to solve it. And obviously there's like, you're going to home roll your own Nginx load balancer and do all that jazz. But frankly, I think Docker and Kubernetes have got it pretty well covered. So I have 2 articles I can share with you tonight. One is essentially building the app that is already built. I did not write the article, I found it. So I'm gonna go ahead and share that that article with you. And it walks you through the setup. If you have any questions about getting it to work, because there are a few things that are incorrect in that tutorial, feel free to hit me up. And then they got a really cool follow-up article as well too. So it's basically taking this app that we have built here and then getting it running on Kubernetes as well. That goes along with Kubernetes called Helm, and essentially this is the package manager for Kubernetes. So typically Helm and Kubernetes go hand in hand. I do have a video series I love on Kubernetes, and I can share it with you. It is behind a paywall. It's on LinkedIn Learning. And then the other thing is that Humble Bundle, I've not checked out this content myself, but Humble Bundle is actually running a book bundle right now. That's not actually books. It is Pluralsight courses on specifically Kubernetes. And so you can get a whole bunch of Kubernetes training content. And I almost guarantee you they cover Docker. Fundamentals, Docker and Kubernetes for .NET developers, Azure. You can get the whole thing for probably like $15. Maybe 25, whatever. I'll pay at least 20. Yeah, pay $20 and you get all of this content. And these are video courses as well too. So I'll share a course. It's just, to step back in 10,000 foot view. The big problems that Docker and Kubernetes solve is Docker, of the two, definitely start with Docker. Docker solves the problem of essentially making sure that your apps are operating in an environment in which they can be run. And it also can simplify the deployment process if you let it. Once you get your apps Dockerized and get them running in Docker, the next thing you'd want to go after is something like Kubernetes. And Kubernetes essentially is going to help you with that, not just the deployment strategy, but also setting up things like health checks, auto scaling, and so forth. And if you take nothing else away from this, one of the big things I really wanted for you tonight was not like going in and doing it yourself. That isn't always the case of Aftercamp meetups, is like convince you to use these technologies, but rather awareness of what problems these technologies solve, so that you understand when you're coding your front end that the backend team is actually having to think through a lot of this, and the cloud, or the cloud team is having to think through all of this. And so you can understand basically the full effort that goes into this. And let's say you are a front end developer, it's simple things like considering, if you're hard coding API routes, for example, and you're not thinking about, for my application, I'm saying go ahead and make a GET request to localhost 3000. Like that's not going to work in production, because the production is going to be all of this craziness. And so it's having that more global view. Definitely would love to talk Kubernetes, Docker and Kubernetes all month. But that brings us to the top of the hour. I will shut up and answer any questions you guys might have. So thank you so much for coming, and I appreciate it. Yeah, that's a really so there doesn't much of a reason to use Docker and Kubernetes on a small project. If I want to make a Sudoku game and even a CRUD app, I'm not really looking to have containerization. I completely agree to a point. It depends on why you're building that Sudoku game and CRUD app. And the reason I say that is because if you are looking to join a team that is using Docker and Kubernetes, it might actually have a huge benefit if you go through the process. Because I can tell you, I can count on one hand how many applicants that I have seen working in both the front end and back end space who have taken the time to deploy their app to Docker and Kubernetes. And when you do that, even if you are the solo developer and there's no real reason for you to dude, 5 people are going to use my app, no big deal. But at the point of making that Sudoku game was to help you job seek, there's a massive benefit to using Docker and Kubernetes. And you're kind of looking at the bigger picture. Any thoughts on deploying on-prem Kubernetes? Oh gosh, we could probably talk at length about that, JJ. I'm definitely happy to take that conversation offline. But let's go. Yeah, let's go ahead because I think we could pontificate go back and forth and trade swings on that. But I don't know if this is the exact right venue for that. More than happy to continue the conversation on Slack though. Hey, if you're not on our Slack group, I know Rachel posted it earlier. Make sure you get on that.
Yeah, I think I do have another question about because I'm about to start a Sudoku app just because I feel like it's a start. If I did want to go ahead and do that, what's like the best place to begin with using Docker for that?
Yeah, I honestly think the article that I'm going to post is like the best place. And I think you can knock it out in like 30 minutes to an hour tops. Like really, like you could probably even take my Docker file largely and just update it with the relevant parameters and probably be fine. So, and then of course, you know, if you're going through it and you have questions, Aftercamp Slack is a great place to ask those questions. But yeah, I'm going to post an article tonight. It's got step-by-step. It actually does a great job walking you through it, getting it set up. And then I think the best time to learn is on your own apps. And so basically taking what you've learned from that article and applying it to your Sudoku game would be perfect.
That sounds awesome. Thank you very much.
Mm-hmm. Once again, I cannot echo this enough. If you on your personal portfolio, make a Sudoku game and launch it with at least Docker, I would be blown away as an interviewer. So I heard another question come in. Go ahead.
So, I mean, this thing, like it's developing an app is already, you know, have the flex stuff. So, would you recommend maybe just building your app and then, you know, after it's completed, like kind of like integrating it with Docker, or should you start right away with a Docker file and all of that fun jazz?
Like a question, I think I say no up to a point. I think it becomes yes after that. I think, you know, even the article itself that I'm going to post tonight is really like they do Docker at the very end. So like, to be clear, it's written by a CI/CD company. So then they go further in the tutorial and they show you how to integrate with CI/CD and all this stuff. But I think, you know, even their approach to how they built the simple app was build the app, add Docker. Now, I think that breaks down. Like right now, I'm leading 2 big projects for a big account of ours. And if I didn't start thinking about this now with like 8 people touching both apps, like it would become complex and kind of nuts. And so from like the principal software engineer point, like I'm thinking about that like during all the architecting phase. In fact, I'm actually getting all of that set up now so that I can like start to watch it. And I'm not trying to solve the whole Docker Kubernetes problem when it comes time to launch to production. Like I don't want to be solving that problem then. That would be hellish. So I think, you know, it depends on the size and the scope of the project that you're doing. But I think, you know, for personal apps, I think it really, you could take old apps that you've worked on already and launch them to Docker. That's completely fine. It'd be good practice.
So you know, like something I experienced, I launched an API, and it was like I figured that it was working. The code was working on my local machine, and it wasn't working on Heroku. Okay, but when I fix it for Heroku, it would break in my local machine. Okay, and it wasn't an architectural problem, you know, but you know, I finally figured it out. But I wonder, like, would Docker have solved that problem right away? Yeah.
Yep. Because if it's running locally on Docker on your machine, it's gonna be whatever Docker is running is gonna be able to run it. So classic case for Docker to really shine for sure.
Is there an easy way to hook up IDEs or code editors like VS Code so you can debug within Docker?
It's a great question. So debugging Docker can be kind of a pain in the ass, right? I think that it can be a massive pain in the ass. And so there are a couple solutions. Andrew, let's follow up on Slack and I can send you some of the stuff that I've seen. I don't have like a silver bullet, but I think that, you know, yeah. So I think that is actually a very good point too. And honestly, you know, I think Docker and Kubernetes are relatively, they consider them kind of like younger technologies. And I think how them years ago. And I honestly think that, like, frankly, like some work needs to be done in that space. I think it gets more eloquent the more enterprise you get, because you can use like all sorts of different logging technologies. So it's just that small to mid-range problem, I think, is where it really kind of becomes harder to work with.
Cool. Even that validation is valuable. Thanks.
Yeah, no, you're not nuts, man. Like that is for sure a thing. especially when you're dealing with microservices. Oh my God. Brandon, I thought you unmuted for a second, man. Do you want to sneak in?
Yeah, I did. So if I was looking to maybe take an old project and spin it up as a Docker file and deploy it that way, am I better off making the database as its own Docker file, or trying to, for instance, integrate into AWS's RDS, handle all of the database work? Can you do a lot of those cloud services run Docker file databases, or do you need to use their services?
You can cut it up and chop it up however you want. So I mean, the thing is that once again, it's kind of that classic problem of like, do you want to maintain it? Do you want to like maintain the database and maintain the Docker file for the data? Because you can definitely just like provision hardware and provision volumes and say like, hey, I really just want to run my own database, and kind of have it abstracted away from RDS or Dynamo or whatever. And the advantage to that, of course, is when it comes time to replatform, like you're good, like you're covered. But if you're going to replatform and you're using RDS or you're using DynamoDB, like replatforming can be a bitch then, right? Because then you're coming off of AWS and moving to like something like GCP, for example. Like you have to like export the data and migrate the data, and that becomes a nightmare. So it's a little bit of like pick your poison. I feel like, is it a future Brendan problem, or is it a current Brendan problem? You know what I mean? And so, and at the end of the day, like I think you present the problems to your clients, and your clients can be like literal clients, or either your clients can be internal. And I think that sometimes like developers keep themselves up at night with these decisions, and they don't have to. You can offload those decisions to business people. It's like, oh, it's not my problem, it's business person's problem. You guys decide what you guys want to do. Because, do you want to kick the can down the road and have a huge replatforming effort, 5 years from now, or do you want to spend extra time to have me maintain all this stuff now? You pick.
Nice.
Delegate. Yeah, Peyton's right, man. Delegation is a skill. And Fernando, yeah, I'll hang out. Fernando wants to ask some questions about not Docker and Kubernetes, but just general stuff. So any final sneak-ins for Docker Kubernetes? Cool. I will post some really great articles that I think you guys will enjoy in the Slack channel tonight.
Thank you, Scott.
Thank you. Thanks for coming. Next time it is the 12-factor app. I'm so excited about that one. And then solid principles after that. Like, we have a really like solid lineup, and then data engineering is how we wrap the year up. So I'm like super excited for the next couple of sessions. Just another quick heads up. I don't know if you guys are familiar with Joe Carlson. He was previously at Mongo. He's now at Single Store. He is actually guest presenting in a couple of weeks. So he's going to be guest presenting on Single Store. It's our first collaboration. We've been talking online for a couple of years. I'm super excited about it. We will announce that session here probably by the end of this week, early next week. But Joe Carlson, the lead evangelist from Single Store, is going to be presenting October 5th, I believe. Yeah, it's going to be great. I love Joe. Cool. Fernando, what you got, man? What do you want to chat about?
Well, come in private after the fact.
I don't know, man. I think everyone could benefit from it. I'll tell you what, we'll stop the recording.